Good afternoon. I am Dr. Neel Kamal, Associate Professor, Department of Electrical and Electronics Engineering, School of Engineering Technology, IIMT University, Meerut. So today I am discussing in the continuation of my lectures based on three-phase induction motor. So this is the part 1. These are the course outcomes for three-phase induction motor and synchronous motor, special machines. In the machine 2 part, there are basically 3 different motors. One is induction motor, second is synchronous motor, and third is some special motors. What prerequisite required for this discussion: elementary physics or 12th level, DC machines and transformer awareness, and basic electrical engineering. First of all, different type of electrical motors we are using here. We can divide it in 2 different parts. One is DC motor based upon DC supply system, and second based upon the AC supply system known as the AC motor. So DC motor have these different parts: permanent magnet DC motors, separately excited DC motors, series motors, shunt motor, and compound motor. The name of these motors has been given based upon the different type of excitations we are using here. In separately excited, as per name suggests, we are having the excitation fed separately, and in series motors we are having the excitation in series with the armature winding, and in shunt motor we are using here the excitation in parallel of armature winding. And this is the compound motor, in which we are using series and parallel excitation on armature winding. And these are about the AC motors. We are basically having 2 different motors. One is known as the induction motor, and second is known as the synchronous motor. Induction motor, we can say, have 2 different parts. One is the 3-phase induction motor, and second the single phase induction motor. So this is the general classification about the electric motors we are using here. This is the learning object about the electrical motor part: analyzing the construction, working principle, starting and speed control, braking system. These are the learning outputs about electric motors. So now we are discussing about the different part of this electrical 3-phase induction motor. One is the general introduction about 3-phase induction motor and its construction, working of rotating magnetic field, and finally the working principle. So I have divided this 3-phase induction motor in different parts. So this part 1 contain these 4 different subparts. First of all, general discussion about the 3-phase induction motor. Why we are using 3-phase induction motor? We know more than 80% of electrical motors used around the world is 3-phase induction motor and single-phase induction motor. I want to say we are using induction motor a lot as compared to other motors. We are having different type of advantages. This motor have comparatively good power factor, better starting torque, and very good in appearance, and efficiency is also good. So there are so many advantages of using this type of motor. And domestically we are also using single phase induction motor. General construction part: this is the induction motor we are using. You can see a look of 3-phase induction motor, in which we are having the terminal box here, and this is the part, rotating part. This is coupled with the rotor part. Shaft is in, this is known as the shaft part, on which we are having the pulley or gearing arrangement here. And this is the specification sheets, in which some information has been written here. General construction, starting from this part: cooling fan, because induction motor we are having stator and rotor winding, in which there will be different type of losses inside this induction motor, known as the copper loss and core loss. So due to these loss, heat will be dissipated. So this heat we have to remove from this system. So we are having the cooling fan system here, and again this is the terminal box, and this is the outer peripheral known as the base of the three-phase induction motor, and inner peripheral is known as the stator part of the induction motor. This is known as the stator part, and this stator part, it is the outermost part. This is the frame. Outermost part is the frame of induction motor, and this is the this is made by the silicon aluminum alloy. This provide the housing of stator, protect the inner part, and also lead the part of ventilation. This is the inner peripheral of the stator part, in which winding is put inside it, and basically we are having 0.35 to 0.65 mm thickness of lamination in this part, and slots are punched in the inner peripheral, and we are having the ventilating ducts here to remove the heat generated. This is also the stator winding part of a three-phase induction motor. Now inner part is known as the rotor. This is the shape of three-phase induction motor rotor, and this rotor is the rotating part of three-phase induction motor, while stator is the stationary part of the three-phase induction motor. So this shape, these are the different slots in this rotor part, and these slots are parallel but some skewed to avoid the magnetic locking system. We are having basically two type of rotor here. One is known as the squirrel cage type rotor, and second is known as the slip ring type induction motor, because in squirrel cage type rotor we are having the squirrel cage type shape, in which this is the circulating ring in both side of this type of rotor. So this is basically for the short circuiting of different bars using here in this shape. So in this way we can say this is already short circuited part of this rotor, and as it is already short circuited part, we cannot enhance, we cannot increase further resistance to this type of rotor. So we are having the different another part of the rotor, that is known as the slip ring type rotor, in which we can increase the resistance, rotor resistance, by using three different slip rings inside it. This is the shape of slip ring type induction motor rotor. So these three are the different rings known as the slip rings. So what is the need of this type of rotor here? Because in starting we know we want rotor resistance to increase or decrease for obtaining the better starting torque, because torque is directly proportional to the rotor resistance. So there is need to change the value of resistance. So this is only the type of rotor in which we can add on resistance by using these slip rings. Actually stator is the stationary part and rotor is the rotating part. Then how we can increase the rotor resistance even we have the rotating part? So this is the special system on which by using this we can increase resistance, because this is the slip ring on the rotor part and it is contacted by these carbon brushes. So by this system only we can give the supply, and we can change the resistance. We are using here the variable resistance connected in star type. Now we will discuss about the production of rotating magnetic field. First of all, let me confirm what the difference between the alternating flux and rotating flux. In single phase supply system we are having a single phase, or we can say just we are saying here just like phi r is written here, r for red system and y for yellow system and b for blue system. This is the nomenclature for three different supply system. So in single phase system we are having only the single sine wave system, so this is alternating by nature. But in case of three phase system we have three different supply vector shape phi and which produce three different fluxes, that is phi r, phi y and phi b here. So what is first of all rotating field and why we need the rotating field? First of all, we can say rotating field can produce if we have a magnet and if we rotate this magnet continuously, then it will produce the resultant magnetic field that will be having constant magnitude, but its axis of rotation is continue changing. So this is known as the rotating magnetic field. Same magnetic field we can also achieve if we have three different supply here, just like in this case if we have the three different supply system. So by interaction of these three different fluxes we can have the resultant flux, and that will be rotating by nature. In three phase induction motor we are having rotating magnetic field by which the torque will be produced here. So these are the three different fluxes, and in balance system we are having the constant magnitude of flux, we can represent it by phi m, and these in balance condition we are having the 120 degree phase difference between them. So we can have the mathematical equations for this system. Phi r, we can say phi r is equal to phi m sin omega t, and phi y is equal to phi m sin omega t minus 120 degree, and phi b is phi m sin omega t minus 240 degree, because we are having equal phase displacement here. So we can say if we divide 360 degree in three equal parts, so we can have 120 degree phase difference between them. So in this way we can say these are the three different equations. And from 0 degree to 360 degree, if we can check at any instant, it will give the constant magnitude as a resultant flux. Just like the example, if we are having the omega t is equal to 0, suppose that omega t is equal to 0, then in this equation phi r is equal to phi m sin omega t. If we are having the omega t is equal to 0, so we can say phi r will be 0. So this is the direction of phi r, so phi r vector is 0 now, so it is denoted by the dotted line, because we doesn't have any vector in this side. Now what about the phi y? Phi y is equal to phi m sin omega t minus 120. So if we put, suppose omega t is equal to 0, so it will be phi y is equal to phi m sin 0 minus 120, or we can say minus phi m sin 120. Sin 120 have the value under root 3 upon 2, but in negative, with negative system. So this is the actual direction of phi y. So due to this result we can say we are having minus phi y in this direction. Now phi b is phi m sin 0 degree minus 240 degree. Why? Because we are putting omega t is equal to 0. First of all, if we are having omega t is equal to 0 for all these three vectors, what the exact values will be? So these value will be phi r, phi y, phi b equal to phi r is equal to 0, and phi y is again repeating minus under root 3 upon 2 phi m, and phi b is equal to phi b sin minus 240, or we can say phi sin plus 120, because 360 minus 240 degree is equal to 120 degree. So we can say phi m sin 120, and its value will be under root 3 upon 2 phi m. So in this way we can say we are now having the all three values about phi r, phi y and phi b. The resultant will be of these two vectors. If we have the resultant, so this will be the resultant, phi res, the resultant of these two vectors. So if we have the two vectors having 120 divided by 2, because all are in balance condition, so we can say phi b and minus phi b. This resultant will be shown by the red color vector, phi res is written here. So if we have the projection of this phi b, we can say cosine of phi b, because if we have a vector at any angle, the horizontal component will be just like, if you suppose that we are having a vector a and that is inclined with angle theta degree, so we can say its horizontal components will be a cos theta and its vertical component will be a sin theta. So in this way, if I have the projection of this direction, because we have to maintain this resultant, so this will be phi b cos theta, and cos theta will be this angle. So this angle is the 30 degree. So, and similarly this minus phi y is also have the projection on this part, so we can say it minus phi b sin 30 degree cos 30 degree, because we all in both vectors we are having the projection of these in same direction of this, so we can say cosine will be taken. So because both are equal, so we are taking here 2, because we have to sum up these two components. So 2 multiply by under root 3 upon 2 phi m and cos 30 degree, because we are having the 60 degree overall angle and just center of it we are having the resultant, so we can say this angle will be 30 degree and this angle will also be 30 degree. So in this case we can say phi resultant is equal to 2 under root 3 upon 2 phi m cos 30 degree, and cos 30 degree is also known as the under root 3 upon 2, and by this calculation we can easily see here resultant will be equal to 1.5 phi m, where phi m is the maximum value of the flux. So this is the example of omega t is equal to 0 degree, but at any instant whatever be the angle we are taking here, we are in the another slide we can say, just like we are having the omega t is equal to 60 degree, we are also having the different value, but in all values I am showing here omega t is equal to 120 degree. So this is the now shape, because it is continuously rotating, and this is for the omega t is equal to 120 degree. Now this is in this direction, just opposite of 0 degree we are having. So by all this different type of angles starting from 0 degree to 360 degree, we are concluding that resultant flux will be equal to 1.5 phi m. So we can say the rotating magnetic field is the field having the constant magnitude and its value is equal to 1.5 time greater than the maximum flux. So these are the conclusion starting from 0 degree to 360 degree continuously, and by this concept we can say we are having the different angle rotating magnetic field system concluding in a single diagram system here. Now what the working principle of 3-phase induction motor? Basically 3-phase induction motor, we can discuss about the squirrel cage type rotor here. When 3-phase supply is given to the stator part, stator winding, it will produce rotating magnetic field as per our earlier discussion. This rotating magnetic field also confined with the rotating part. Rotating part is the rotor side. So all rotor slots are short circuited by the short circuited ring. In previous slide I am just going back to show you a diagram. This side, all rotor slots are short circuited by this ring and another ring is there. So this is the short circuited rotor. So when this rotor is placed inside the stator part, in peripheral part where the rotating magnetic field is also there, so there will be induced EMF, and by this short circuiting system we are having the short circuited current inside this rotor system. This short circuited current will circulate in this rotor ring system here, and it will produce the torque. Basically this concept is based upon the relative motion of the synchronous difference between the synchronous speed and the rotor's actual speed. There must be a relative motion between them. Two speeds I am saying here, synchronous speed and the actual speed of rotor. This difference we can say ns minus n, where ns is the synchronous speed of the rotating magnetic field and n is the actual speed of the rotor, and the rotor speed is proportional to this relative speed. So at starting where rotor speed is at standstill, or we can say n is equal to 0, there will be maximum relative speed. So rotor speed is proportional to the relative speed of this, or we can say ns minus n. So there will be production of torque inside this rotor system, and it will try to overcome this difference. That is why rotor start rotating to compensate this difference continuously, and rotor again and again getting the increase in speed. When its speed is reached to the near about synchronous speed, suppose that we are having the rotor speed equal to synchronous speed, means now there is no relative speed, ns minus ns, we can say 0. So there will be no relative speed. No relative speed means no torque is developed now. So in this case rotor again have decreasing in speed, and whenever the decreasing speed is there, there will be the again setup of relative motion, relative speed between them. So again it will cover the torque. So in this way we can say three-phase induction motor always run with the speed slight lesser speed with the synchronous speed, but never attain the synchronous speed. Again I am going the one part of this. So this is about the working principle of three-phase induction motor. This is the magnitude of induced EMF 4.44 kW1 N1 5 RS and F volts, where these are the different parameters and components using here in these equations. So thank you very much, and in the second presentation I will discuss about the different rotor parameters. This is the derivation type part here, so I will discuss in my second presentation. Thank you very much.